Okay, hello class. So earlier, we already discussed the position, velocity, and acceleration. So we nato duha ka relationship na ay average na velocity and acceleration. And then there is also the instantaneous velocity and acceleration. So there are important formulas that we need to remember. So this one, diba, in your mathematics, differential calculus, let's kuan lang no. Review a little bit. Natay gitawag nga function of x or y. So y is equal to f of x. Now if we derive y, we call that y prime. So another niya nga itsura is uh, derivative of y with respect to x. That's y dy over dx. Okay? And then the second derivative of y is d squared y over dx squared. So mo ni siya. Same also with the position, velocity, and acceleration. They also have a relationship. So S, di ba, is the position. So the first derivative of S or the position. So kaning S prime diriha is derivative akong pasabot aniha. Dili na siya katong final position akong discuss earlier. So the first derivative of the position is equal to, with respect to time, is equal to ds over dt. Now we know that the derivative of s with respect to time is equal to the velocity. So ang first derivative ni position or s prime is called the velocity. The second derivative of the position represented by d squared s over dt squared. So yan yung itsura ni no. So mo ni siya. So the second derivative of position is represented by d squared s over dt squared. So it means that the position is derived twice with respect to time twice. So other niya nga pagkasulat is looks like this. So d over dt times ds over dt. Now, if you look in this part here, it looks like this. ds over dt. So it means that the second derivative of position, we can write it in formula. Since v is equal to ds over dt, we can write it as like this, dv over dt. And then we know that the derivative of v with a velocity with respect to time is the acceleration. Okay? This is the acceleration and then the velocity. So we need to remember these formulas. Okay? Velocity is derivative of position with respect to time, ds over dt, and the acceleration is the derivative of the velocity with respect to time. So this is an important topic as we discuss further in these lessons. Okay. So here there are the three most important equations of kinematics. First one, kato akong mentioned, v is equal to ds over dt. Acceleration is equal to derivative of velocity over time with respect to time. And then this one, a ds is equal to v dv. Okay. So now, what if the object is in constant acceleration? So if the object is in constant acceleration, we have a new set of kinematic formulas or kinematic equations. So it was shown here. So constant ang acceleration. It means it's either that the velocity is increasing or decreasing at a constant rate. So natay first equation nato diri I will going to write here. Velocity, final velocity is equal to the initial velocity or v naught plus or minus the acceleration times the time. The second important formula here as shown here, it is the position. S is equal to, the final position is equal to the initial position S naught plus the initial velocity V naught times time plus or minus 1/2 acceleration times the square of time. And then the final formula, v squared equals to, so I'm going to write it. The final formula in kinematics, we have the square of the velocity is equal to the square of the initial velocity plus or minus 2 times the acceleration times the position, final position s, minus the initial position. Okay. So, sir, ganong velocity times time. So, we know that if you multiply velocity to the time, you will get the position or meters. Okay. That's why naka-square po ni siya dire. So, ako lang ning i-rewrite for you. So, ato lang ilalay, no? S, okay, since position, wala itong first history, S, our final position, is equal to initial position times the initial velocity times time plus or minus 1/2 acceleration times t squared. So, sir, nganong na minus? It is because acceleration may be positive or negative. If the velocity is speeding, then it is a positive acceleration. If the velocity is decreasing, then it is a negative acceleration. Our second here, we have the velocity. Final velocity is equal to initial velocity plus or minus the acceleration times time. So, acceleration times the time is velocity. The third one, we have the v squared is equal to uh, v naught squared plus or minus 2a times the final position times the initial position. Now, if you remember, final position minus initial position, we call that the displacement. So, this formula we can write is like this. Square of the final velocity is equal to the initial velocity squared plus or minus 2a delta s. Okay. Take note of these formulas. Okay? You can pause it if you want. So let's proceed. These equations are only valid when the time is equal to 0 and the acceleration is constant. Vs, velocity, and the position are final velocity and the displacement, respectively. V naught and S naught are initial velocity and displacement, respectively. And then AC in this equation in your module is the constant acceleration.